All right, today's focus for our AP Pre-Calculus section 1.2 is rate of change. In topic 1.1, we learned that the phrase rate of change is synonymous with the word slope. So a positive rate of change indicates that a function has a positive slope. The function is increasing. And a negative rate of change indicates that a function has a negative slope, that the function is decreasing. So right here it tells us that the rate of change at a point, and we're going to stop and just talk a little bit about that vocab, making sure that we got the right one for AP Pre-Cal. In AP Pre-Cal, we will define the rate of change of a function at a point as the rate at which the output values would change if the input values were to change at that point. In AP Calculus, you will call that instantaneous rate of change. But the concept of a function changing instantaneously is called a derivative and is quite challenging to understand without first learning the foundational ideas from our AP Pre-Cal. So in AP Pre-Cal, we're unable to find that way. So we're going to find the rate of change of a function at a given point by closing down our intervals. But we need to determine if the rate of change of at a given point is positive, negative, or zero. So we're not going to find that instantaneous rate of change. We're going to leave that for AP Calculus. And so we are going to just find what's happening at that given point, whether it's positive, whether it's negative, or zero. And we'll need to be able to compare that rate of change at two distinct points. That's what we're going to focus here in AP Pre-Cal. All right, at the instant, which is the point, when you are at the top of a peak or at the bottom of a valley, you are not moving up or down. So at that single instant or point, you are changing between going up and going down. At these points, the rate of change is neither positive nor negative. The rate of change is zero. So that's why we say here positive, negative, or zero. So we said when we have a positive rate of change, then the function is increasing. When we have a negative rate of change, the function is decreasing. And when it is zero, it is at that point where they are not increasing or decreasing anymore. So it's that point where it's changing. So let's look at that as a roller coaster here. As we are going up, this is increasing. So we have a positive rate of change. When it gets to this top point right here, you kind of do that little stop right there. So it is not increasing or decreasing there. That is when it is zero. Then as we go down that little hill there, our function is decreasing here. This is where we have a negative rate of change. So if we call this point T1, this T2 and T3, we can say that at T1, the rate of change of f is positive. At T2, which is this one right here, the rate of change of f is zero. And at T3, the rate of change of f is negative. Okay, so kind of think about that as a little roller coaster there. We've got our increasing. So if you see our tangent line right there, and remember from geometry, a tangent line is when it touches at one point. So we drew our little tangent line right there. At that one point, this has a positive slope. This has a zero slope. Remember, horizontal lines have a zero slope, so our tangent line is horizontal there. And then our tangent line here has a negative slope. So that's another good way of testing it. All right, so we're going to look at some examples of that. On here, we have graph H. And it tells us in this example, the graph of H is shown above or next to us here with 4 points A, B, C, and D. Sketch a line tangent to the graph of H at the 4 points indicated on the graph. So again, we said that a tangent line is one that touches at that one point. So we would only want to touch at that one point. So if I draw a tangent line, I would go to that one point right there. And I'm not going to cross on that graph. I'm just going to touch that one point. Now my marker's a little thick here, so it looks like I touched, but we're just coloring that picture right there. For B, in order to go through that point, I would go over here. And so that looks like that. And then for C, we're up here. And then for D, we're this way. So I just drew the tangent line. The tangent line is that, again, that line that touches the graph at that one point. So I drew our tangent lines like it said there. Now it says order the rates of change of the graph of H from least to greatest at the points A, B, C, and D. So let's think through that real quick. On this graph right here, A, my tangent line is decreasing, so I know it has a negative slope there. For B, it has a positive slope because it is increasing right here. We've got a positive slope. We've got a zero slope on the C. And then on the D, we have a negative slope again because our tangent line is decreasing there. So we've got that negative slope. It wants us to order these from least to greatest. So my two smallest ones are going to be this A and this D tangent line. So the next thing I would want to do is you can take a couple points here. So this goes down 1, 2, and to the right 1. So we've got like a -2 approximately. For this one here, if I went down here, I went down 1, 2, 3, and over 1. So this slope would be approximately -3. And those are just approximations because I just took them from the graph there. But this is a smaller number than this one. So this is going to be my smallest, D, and then A, and then the next one would be 0. So that would be C. And then this one has a positive slope, so B would be the greatest. All right, for this next example, it says the figure shows the graph of a function f in the xy plane with 3 labeled points. Order the rates of change of f at the 3 labeled points from least to greatest. So this is kind of an example the same as that other one. So go ahead and pause it and try it yourself before seeing our answer. So here's what you should have gotten for this one. And I didn't even have to draw the tangent lines here because I see this is increasing here. So I know that this one is positive. On B, it changes direction right here. So it's starting to decrease there. So B's on the decrease side. So it is negative. And then C is on that peak. And so it is 0. And so then I can do our graph from least to greatest. And so I've got my negative, my 0, and my positive. I did put here ROC, that stands for rate of change. So when you see ROC, that stands for rate of change. Keep that in mind. All right, on the bottom here, there's another question that we could see. It says the figure shows the graph of a function g in the xy plane with 4 labeled points. Of the following points, at which is the rate of change of g the least? So in this case, instead of ordering them, we're just looking for the smallest one. I can immediately say B is out because that was a positive slope, so it can't be that one. Same thing with A. This is my peak here, so this is increasing, so I can knock that A out as well. Now C is decreasing, and D is on the decreasing here. Both of these are decreasing, so it's going to be one of those two. So I would want to go ahead and sketch my tangent line so I can figure out what the slope is at that point. And so there is the C one, and then I want to do the same thing for D. If you're good at looking at those graphically, then you should already know which one is the steeper line, which one's going to have the most negative slope, which in this case is D. We can see that this one is decreasing at a much faster rate. So that's going to be my least rate of change. If not, again, pick some points and go sketch it. And so that you'll find that D goes down very quickly. It goes down 1, 2, 3, and over 1. So this is going to be like a -3 slope. This one here is about a -1 approximately. And so this would be my smallest number. All right, so let's keep talking about average rate of change. Tells us here that another important concept that we will use throughout AP Pre-Cal and and AP Calculus is the average rate of change of a function over an interval. So now we're not talking about just that one point. That's the difference between that rate of change, and then this is average rate of change, which we see here is the AROC. The average rate of change of a function over an interval is the constant rate of change that yields the same change in the output values as the function yielded on the interval. It is the ratio of the change in the output values to the change in the input values over the interval. We will look more closely at the average rate of change of a function in the topic 1.3, including how to calculate the average rate of change over a given interval. In 1.2, we will approach average rate of changes in a way that is very similar to how we approach the rate of change at a given point. We will determine if the average rate of change over an interval is positive, negative, or zero, and we will compare the average rates of change over two distinct intervals. So there's a formula for that, which you saw in Algebra 1, basically. It's an average rate of change is f of b minus f of a over b minus a. And so we know f of b, that's our y value, minus f of a, that's our y value at a. And then these would be our x values. In Algebra 1, you saw this as the slope formula. And so in Algebra 1, you saw y2 minus y1 over x2 minus x1. Remember that formula? This was from Algebra 1. And so when we talk about any function in any 2 points, we really write it this way, f of b minus f of a over b minus a. On the interval from t equals a with units, so we want to make sure we put our units, and then time b is with units as well. The function in context is increasing or decreasing on average at a average rate of change with the units. So that it looks like a lot more complicated than it really is. So let's look at a problem. It tells us here, we've got a table now. Our birth years are 1800, 1850, 1900, 1950, and 2000. And it wants the life expectancy, or here's the life expectancy of that, 41.24, 46.10, 53.63, and 70.65, and 81.83. The table gives the life expectancy of U.S. females born in a given year over successive 50-year intervals. Over which of the following intervals is the average rate of change in life expectancy the greatest? So from 1800 to 1850, well, these would be our x values or our independent values. So that's my b minus my a. I take 1850 and I subtract the 1800. On the top here, it would want f of b minus f of a. So f of b would be, what is the value of the function at 1850? Well, the value of the function at 1850 is 46.10. So I would do 46.10 minus, at 1800, it has a value of 41.24, and then 1850 minus 1800. And so then you can put this one in the calculator. And so we get 0.0972. We would repeat that for B, C, and D to find which one is the greatest. And so at 1900, it's 53.63. At 1850, we said that was 46.10. And then again, this is going to be 50 years since that's going to be 50. So each one of these is going to come out to be 50. And I put that in my calculator and I get 0.1506. For my next one, 1950, that's 70.65. 1900 is 53.63. Again, 1950 minus 1900 is 50. And I put that in my calculator and I get 0.3404. For my last one at 2000, it's 81.83. 1950 is 70.65, and we're over 50, and that one gives me 0.2236. And so when we're looking for our greatest rate of change, well, here's my rate of change, the average rates of change. The biggest one is going to be this one right here, 0.3404. That gave me my greatest number. So C would be the correct answer here. All right, let's look at another example of that. And this one kind of brings today's lesson and that instantaneous one back together. The temperature of a pot of tea as it is cooling is given by the function h of t in this table right here. How fast is the tea cooling on average over the 10-minute interval? Show the work that includes units. So here is my 10-minute interval. So I use that formula. So it's going to be f of 10 minus f of 0 over 10 minus 0. And so at 10, it is 43. At 0, it is 66. And then 10 minus 0 is 10. And so we get negative 23 over 10 is equal to negative 2.3 degrees. I'm sure when I'm writing that out, I could just put the degrees Celsius per minute. All right. Estimate the rate at which the temperature of the tea is changing at t equals 3.5 and explain your method. So right here, we found the average rate of change from here to here. At t equals 3.5, that's a singular point. That's what we talked about before. Now, in order to find the exact value, we would have to do the instantaneous rate of change, which we said we need calculus for. In pre-cal, we can do this by closing in this interval. So 3.5 would fall between these 2 points. So I would close up that interval and I would do f of 5 minus f of 2, because those are way closer to this point right here, so I can get what's happening at that point. And then the 5 minus 2. So we get 52 minus 60 over 3, which is negative 8 over 3. If we used a calculator to round that, we would get negative 2.667 degrees Celsius per minute. Now, anytime it says explain your method or justify your answer on the AP test, you do have to write out what you're doing. And so we took the values closer to 3.5 and found the average rate of change. On the test, you should go ahead and write that out, but that's what that AROC stands for, is the average rate of change. All right, we're going to look at that from an equation standpoint. So we just did some tables. We said we're going to do the multiple representations all over AP Pre-Cal. They could ask you the question in any of those forms when you get to the test, so we want to make sure we're covering all of them. And so in this case, they're giving you an equation, and they're telling you the intervals from -1 to 4. So your formula is still going to be the f of 4 minus f of -1 over 4 minus a -1. So now I find the value at 4. And so remember, I could do that to the side if you want. So f of 4, that's when we plug the 4 into the x. So 4 is my input value. So I do 3 times 4 plus 4. And so that is 12 plus 4, which is 16. And the square root of 16 is 4. So f of 4 is 4. So I would get 4 here minus. Now I need to find f of -1. This is my input value in the function f. So there's my function f. I put in my input. And so I get 3 times -1 plus 4. 3 times -1 is -3 plus 4 is 1. And the square root of 1 is 1. These two signs cancel out. So that gives me a 5 there. 4 minus 3. I'm sorry, 4 minus 1 is 3. over 5. And so that would be our average rate of change right there, would be the 3/5. All right, so let's look at another problem here. This is going to give me context to go with it, and it's giving me the context and it's giving me a graph, so we're going to put those together. Over time, all economies go through regular cycles of expansion and contraction. This is called the business cycle. Today, we'll look at a graph depicting how gross domestic product, GDP, changes from respect to time. So here is our GDP graph that we're using. At each of the points A, B, C, determine if GDP is increasing or decreasing. And so we're looking at these 3 points to start with, the A, the B, and the C. And so at point A, my graph is increasing. Because it is going up from left to right. At point B, the graph is decreasing because it hits my top part here and it starts to go down. So we are going down here, so this is decreasing. It continues to decrease until it gets this point. So at point C, the graph is decreasing as well. All right. Part B says the maximum and minimum values of a business cycle are called peaks and troughs. Label them on the graph. So on this graph, this would be considered a peak, and this would be called the trough. And so we have another one here, peak. So I have labeled them on my graph. As we move further into polynomials, we'll talk about what those values are called in mathematical terms. So the maximum and minimum values, we just labeled them. What can you say about the rate of change of GDP at these peaks and troughs? And so we talked already, the peaks and the troughs here, the max and mins, that is when we are changing in direction. And so our tangent line is horizontal, so it has a slope of 0. So the rate of change there is 0. I'm going to go ahead and write there, max or min values have a slope of 0. So you can remember that one. All right. Is GDP increasing and decreasing at a constant rate? And so our answer to that is no. Remember from Algebra 1, in order for it to be increasing or decreasing at a constant rate, it needs to be linear. This is not linear. It is increasing and decreasing at different rates. So no, the graph is not linear. All right, at point D, GDP is increasing. Is the growth in GDP speeding up or slowing down, and how do we know that? So point D is this one right here. And the growth there is slowing down. And so let's talk about that. You can tell because the graph is less steep there, so we know the rate of change is slowing down. You can also know that because it is concave down. This is concave down right there, so we know that the average rate of change is slowing down. All right, when is GDP changing the fastest? And how can you tell this from the graph? And so the fastest we can see right here at BC, at FD, and then right before E. That's where we have our steepest lines. So let's write that down. So between B and C, sorry, not D, B and C, F and D, and before E. That's where our steepest lines happen. All right, at point E, is the slope of the curve negative or positive? And what does this mean in the context of the problem? So now we're looking at point E, that's this one right here. And our tangent line there would be decreasing, so the average rate of change there is negative. And so that tells us that the GDP is decreasing at point E. All right, and our last one here, at point E, are the slopes increasing or decreasing? What does this tell you about how GDP is changing at that part of the business cycle? So the slopes are increasing. And so that's kind of confusing because we just said the slope is negative at point E, but the slopes there are increasing because this is concave up. And so remember, our average rate of change is increasing when it is concave up. So slopes are increasing because it is concave up. So there's a lot of different questions that they can ask you, and some of these can get tricky and confusing. You really want to think through the problem and understand those vocab words really well. All right, that is our average rate of change. We'll continue with that next class.